Okay, this one, it seems really simple, but it has some kind of complex physics in it. This is part D. This is the hardest part of the chapter we're going to do. If a student is this far from Earth, so a little bit further than the surface of the Earth, right, 6.9 times 10 to the 6 meters from Earth, what's the velocity centripetal? So I'm going to start out by underlining velocity centripetal. Meters is a radius, right? Remember this from the other day. What's the velocity centripetal of the student? So what we need to know is we remember that whatever the force that's making it go in a circle, so right now we're assuming this is an orbit, that force is the velocity centripetal. So if that's the case, I can make these two equations equal to one another. Watch this. So since force gravitational is the force centripetal, I can go ahead and just make, remember mass 1 is Earth, 2 is the student, divided by the r squared, but we know that this is the force centripetal, so I'm going to use the equation we've been using for force centripetal. M squared, mv squared, mv squared over radius. And guess what? This is mass 2 over here. You might notice that, oh man, we don't have like any of these givens except for the Earth mass. We have this. We're given the radius, but guess what? This is still the radius, and this mass 2 is the same. So what I'm going to show you right now is kind of weird. Watch this. I need to solve for velocity, right? So I'm going to do that by dividing by mass 2, right? Because it's on top, so I have to get rid of it. And look what's going to happen over here. Mass 2, mass 2. So I never even needed the mass. Okay, now my new line looks like this. GM Earth divided by radius squared equals b squared over r. Now I have to get rid of this r. It's dividing, so I multiply. Multiply over here. And guess what? This cancels out. The square cancels out. So now I'm left with g, which is the gravitational constant, which is a given, b squared. How do I get rid of a square? That's right, I have to square root. Oh, forgot the r, right? Square root the whole thing. All right, so now we have a really simple equation. All right, it's simple, but now we're going to plug in some big numbers. So to find out the velocity, square root g is 6.67. I would double parentheses this in the calculator. E negative 11, and where did I get that from? That's a given. Okay, that's up here. That's up here. Okay, close the parenthesis on that. Multiply the mass of the Earth, which is always going to be given. 5.97 times 10 to the 24. These are big numbers, but it's really not that big of a deal. E 24. And then we're going to divide by the double parenthesis that. Divide by the radius, which is this right here, right? That's what we labeled. 6.9 E6. All right, I have parentheses this as well. Put this on the calculator. Square root, double parenthesis, 6.67 E, which is that second E, negative 11, close parenthesis, open parenthesis, 5.9 E24. Is it 5.9? 5.97. So 5.97. You can't leave out little decimals in this one because you're going to mess up your number big time. Divided by parenthesis 6.9 E6, close parenthesis. All right, we get, where'd it go? It went away. Do it again real quick. .97 E24. Close the double parenthesis. 9 E6. All right, we get. I'm getting a weird number. Hold on a second. Let me do it step by step instead. 11, because I'm not getting what I want right now. Maybe I am. All right, there we go. That's a much more reasonable number. All right, so after all that, we got about 7,552 meters per second. All right. So now, the next question they might ask is, what was the period, or how long would it take for this to orbit around Earth? Well, period is equal to seconds, right? Seconds per cycle. But it's also part of the equation for velocity centripetal, right? Which is 2 pi r over period. This is the one we want to use right here. We don't really want to use this. This is what we want, because we have the velocity centripetal from this last problem. We still have the radius. So if I have a top and a bottom, I can switch these out. So my period is equal to 2 pi r over my velocity centripetal. So period is equal to 2 pi, the radius of the Earth, which was 6.9 E6 E6. Come on now. 6.9 E6. Come on. I can't get this to right. Let me rewrite this over here. T equals 2 pi 6.9 E6 over my velocity, which is about 7,500 meters per second. And now we put that in the calculator. 2 pi 6.9 E6 divided by 7552. So we get about 5,740 seconds. And if we divided this by 60, we would get it in minutes, right? We get it in minutes. Let's divide that by 60 and let's see how long it would take. About 95 minutes, more than an hour and a half. Okay, so that's how you do the period and the velocity.